Oh, hello. I didn't see you there. How would you survive a neutron star? In Infinity War, no spoilers, let's keep the chat spoiler free, but in Infinity War there is a neutron star, and these objects are arguably the most extreme objects in the universe. They have magnetic fields that could wipe your credit cards and hard drives from 1,000 kilometers away, and if you got even closer, they would turn all of your atoms from more of a spherical shape to more of a cigar shape, which would result in you gooifying. Also, if you traveled anywhere near their surface, their immense surface gravities would accelerate you towards the surface of a neutron star at millions of meters per second. A good fractions of light speed. But don't worry, you wouldn't impact in one piece. You'd already be turned into human spaghetti paste. So, given all of these ridiculousies, trademark, how could you possibly survive being near a neutron star? Well, scientists have actually tried to figure this out. How far away could you be from a neutron star as a planet with an atmosphere and still survive all of the radiation, mostly X-ray radiation, that a neutron star puts out? To do that, they make a graph like this and they take data. On this axis, the y-axis, we have luminosity, which is how much radiation is coming out of the neutron star. And then on this axis, on the x-axis, we have astronomical units on a logarithmic scale. This scale is also logarithmic. So, where is the habitable zone? Where could a planet be in relation to a neutron star such that the radiation that it is receiving is neither too hot nor too cold? Well, it turns out that that habitable zone, at least on the papers that I could find, is, assume these are straight lines, is right here. As long as you are within this zone, you are fine as a planet, assuming that your planet has an atmosphere and that atmosphere is absorbing just the X-ray radiation coming from a neutron star. Then, in this Goldilocks zone, you could live in the orbit of a neutron star. If you're too close and the neutron star is putting out too much radiation, it's a young and hot neutron star. It's all hot and bothered, as young things usually are. You're going to lose your atmosphere and you're going to die. If you're too far away and the star is later on in life and not as hot and heavy anymore, I don't know why I'm talking like that, then it'll be too cold and life will be pretty much frozen and also dead. But if you're in here, and let's say that you have a decently luminous neutron star, let's say around here, you go to 1 AU, that's one astronomical unit, and that is defined as the distance between the Earth and the Sun. These things are not to scale, around 93 million miles. And 1 AU, if you're around this neutron star of this luminosity, we could be orbiting a neutron star and be okay. Of course, it would change how all life evolved because you're not getting the same photosynthetic organisms because most of the radiation is in the form of visible light. But there is a band where you can live around the most extreme objects in the entire universe. How cool is that? And what? I'm pausing and fixing my shirt? That's because this is Because Science Live. Welcome to another edition where I try to take your nerdy questions and answer them off of the top of my head to the best of my ability so that we can all get a little bit less dumb. That's all I try to do every day in my own life. This is tangentially about Infinity War, but we do not have to talk about Infinity War and keep the chat spoiler free. I'll give everyone about another week before I am straight up spoiling stuff. Got Nate here, got some questions. What's first?
From Andrew McCarthy. Is it possible to live forever by turning humans into cyborgs?
Is it possible to live forever by turning people into cyborgs? Well, I got a question. Do you really want to live forever? Forever. Wait, can we get flagged for that? Oh. I think what you're getting at is if you were to download the consciousness of a person into something that could be replaced over time, you can't replace your brain, but if you could replace a hard drive and just keep offloading your consciousness onto it, you could live forever. But do you really want to live forever? I don't know. That is the kind of technology that is very hard to extrapolate because we do not even have a great theory for what consciousness is. And we may not have to understand what consciousness is fully in order to replicate it. We might just be able to make a sufficiently advanced computer and it will just gain sentience, which would be really scary and weird, kind of like Johnny Depp in Transcendence. The scary and weird part, not the... So we don't even have a great theory for what consciousness is. We'd have to figure that out, or at least get to the computing power problem a bit more directed. So we don't know how you could download consciousness, or even if you could reduce your consciousness in your head to something that you could move. It could be much more complicated than that. I sound like I'm rambling because I really don't know. It's a very complicated problem answered by neuroscientists and philosophers better. Hey, what's next?
From Tesla Ranger, is the MCU Tesseract, the thing that holds the Space Infinity Stone, really a Tesseract 4D cube?
No. The Tesseract in Infinity War is not a Tesseract in that it's a 4D cube. Does it ever, in the first Avenger, do they show it like a 4D cube? A hypercube, so to speak? Imagine this. It's really hard to think about fourth dimensional objects. I think Carl Sagan had this example where imagine a dot, one dimension. Line segment, 2 dimensions. Oh, wait. I can't. I'm a 2-dimensional creature in this universe. I can't. Problem solved. Just imagine it. Now, 3 dimensions. Now, if I were to put a, let's say, oh, that's not right. Now, if I were to make a really weird cube. Whoa, perspective is hard. Okay, so we got a weird cube going on here. But if you can imagine an object that every side of that object was a 3-dimensional cube, as I have drawn so perfectly here, then you'd have a 4-dimensional object where all the sides of that object are 3-dimensional, which I can't really show you. And even if I could, you know I wouldn't draw it correctly. So it's very, the Tesseract in the MCU is more just like a simple cube. They call it a Tesseract because it's cool. What's next?
From Redheaded Mastermind, why is it that sometimes after coming back inside on a bright day, black ink looks green?
What? Does it? Does it? The only explanation that I can think up off of the top of my head is that your eyes adjust to the incoming light, and the longer your rods and cones are exposed to certain kinds of light or not, the more your eyes adapt to seeing things. There's a fun experiment that I did as a kid when I saw the Mythbusters episode, where if you cover one eye for 20 to 30 minutes, and you expose that, so to speak, to a lack of light, then it will adjust to more nighttime viewing, so you can see things in less light. So the Mythbusters theory is that there were pirates who wore eye patches not because they didn't have an eye, but because if they ever went below deck, they could just switch eyes, and that eye would be ready to go in terms of seeing in low light, which below the deck of a ship would be. So I imagine what's happening with your ink is that your eyes are not fully adjusted to the light environment that you are now in. I would give it a few minutes, and then it'll get less weird. What's next?
From Sir M. Chops.
This is terrible. This is embarrassing. So usually I would just redo this, but I cannot because it's living forever. What's next?
From Sir M. Chops. Hey, I have a question for Kyle.
No, all right.
Is it possible to add enough hydrogen to a gas giant planet like Jupiter that after a certain point it will begin nuclear fusion in its core and form a star?
I have no idea. I honestly have no idea. But I know that a process like that, I don't know if the Jupiter or Saturn thing or whatever you mentioned, I don't know if that is possible to activate nuclear fusion in the core. I will, however, say that sometimes stars, if they're not going to explode, if they do not have the mass to go supernova, there can be situations where they are they are near stars, which I'm saying perfectly. They're near stars, and because of the difference in gravity between those stars, the larger star can start to siphon off mass. It's drinking that other star's milkshake, so to speak, Eli. And then that star will gain enough mass to undergo a change that it wouldn't otherwise undergo, whether that be forming a neutron star or going supernova or whatever. But there's a lot of weird stuff that can happen in space, and because of the gravity of these two different stars, it can drainage of mass from other stars. Large stars that do this are the Daniel Plainview. Dang it! Are the Daniel Plainview of the universe. And they're family man. I hope you agree. I don't what percentage of people is going to get a there will be blood joke? Who knows? What's next? Man, it does certainly look like I have a Y incision on my chest, doesn't it? When my hair's not down. A lot of people say it's like, wow, it looks like you've been autopsied. And I have to agree. I'm not going to tell you what it is. I like to keep up the dead mystery. Go ahead. Help me out.
From Gladzet. Hey, potentially stupid question.
Oh, we'll see.
But does gravity influence sound? If you played guitar on a spaceship, would it sound the same?
This is complicated because there are many moving parts to your question. If you played guitar inside a spaceship, would it be different? This experiment has already been done. Commander Chris Hadfield played that David Bowie song inside the International Space Station, and it sounded like a David Bowie song, because the International Space Station, at the height that it orbits, is still under like 90% Earth gravity. Even though it's hundreds of kilometers above us, it still has basically Earth gravity on it. That's why if the ISS ever stopped orbiting, the astronauts would stop being weightless. So, first part of your question depends on where the spaceship is. If it's close to us, the gravity isn't really that different. Second part of your question, what makes sound audible to you are the pressure waves that sound is. And the pressure waves travel from the instrument or your mouth or whatever it is to your ears, and your ears interpret those vibrations as sound that we hear and our brain makes into sound. So the air that those pressure waves travel through is going to be very important. And what is the air on a spaceship? Again, if it's something like the International Space Station, it has a pressure around 14.7 pounds per square inch of Earth air. That is atmospheric pressure, because we want astronauts to be in an environment that they are used to, that human bodies are used to. So a spacecraft would probably have the air, both the same air, or more or less the same air at the same pressure that whatever the occupants were used to. So it stands to reason that the instruments will also sound the same, because the air is almost exactly the same and the sound travels through that air. As to whether gravity would affect the sound if you were further out from a source of gravitation, I don't know. But I'm leaning towards probably not. What's next?
From Reth Allen. How would a wormhole look to the human eye, and how would it affect space-time?
Whoa. So If I can't draw this, I definitely cannot show you how a wormhole will look. But I will say that there are, just search on, if you're on YouTube, keep this window open and open up a new tab and just search for a wormhole visualization. In the movie Interstellar, for example, there are Kip Thorne, who recently won a Nobel Prize, did the research for that movie. And they used real equations to show what the inside of a wormhole would actually look like. And the light, how it looks, we actually have simulations of that. You can find videos of that across the internet. So I would say go and check it out. I will also say that the light is warped in a way that is confusing but not mind-bending. It makes sense if you're willing to accept it. Sounds like a weird elder god kind of thing. What's next?
From Brucifer, how much storage memory in bytes does the average human brain have?
I don't know. The storage capacity of the human brain, I think, I've seen calculations for it. I forget what they are off the top of my head, but they all have to make a number of different assumptions as to how the brain is modeled. These make assumptions based on, say, the connections between neurons. That we're assuming that based on how many neurons you have and based on how many connections they make, we can think of these like bits. But just like we don't have a great idea of what consciousness is and how it works and how you can mess with it, we don't have a great idea of how our actual neurons would correlate directly with a form of data. All of the numbers that you might see online are based on assumptions. So we don't have a hard value for how much storage capacity you have. But I would go out on a limb and say you're probably never going to run out of it. Because if anything, you'll just start forgetting stuff. What's next?
From Craig Kogan. Ooh. If gravity suddenly stopped being a thing, would things start floating or stay stationary until given some type of directional force?
If gravity stopped being a thing. Well, since I don't have that color anymore. If you were on the surface of Earth and gravity stopped pulling you towards the center, you would find that because you are spinning at a at I think it's around 1,000 kilometers an hour. Might have to double check me on that, but I think it's 1,000 kilometers an hour just spinning around. And if gravity suddenly stopped, it would be like if you were being swung around, if a friend grabbed your arms and was swinging you around in a circle and then let go. The force that is keeping you at your friend ceases, and therefore you are now going to, at whatever path you were at, you are going to fly out tangentially into space at 1,000 kilometers an hour and never be seen again, probably. Now, if you were at Earth, I wonder what would draw you in gravity-wise. In about 15 seconds, it wouldn't matter to you anyway. It'd be bad. What's next?
From Liquor Fan. Hey, Kyle.
Yeah, a little subtle, huh, buddy?
You already told us why we don't want super speed. Now, can you tell us why teleportation would be terrifying as well? If I teleport to the other side of the planet, would I fly off of it?
Yeah, why you don't want teleportation is on my list of other things to do. And we mentioned something like this on a previous live, but you're right. People or creators and comic book writers and what have you forget that time and space are linked. You can't have, as Neil deGrasse Tyson says, you can't have a time without a place, you can't have a place without a time. So if you were to teleport to the other side of Earth, if you were covering enough distance through space, Earth may have moved in its rotation enough that you could be above the planet, or in the planet, or in space, or dead. You could probably just come up with the coordinates in your head if you were a mutant to make that work, but I think that's one of the pitfalls that people don't usually think about, and that's what I like. So yeah, I might get to that. Who knows? Also, you'd make a bunch of sonic booms wherever you went. We'll go through it. What's next?
From Bubba Hotep 1.
Bubba Hotep.
Do you think we will solve the fusion problem within the next 50 years?
Dude, I don't know what's going to happen in the next 5 years. Have you been on Twitter? It is a garbage fire out there. No, I do not know if we're going to solve the fusion problem. I mean, we already have experimental fusion reactors, but we haven't been able to get more energy out of it, or a viable amount of energy out of it than we are putting in. So we're already doing that. But as far as timescale, I have no idea. I'm not in the industry, and I'm not a physicist, so that'd be very hard to say. But within a human lifetime, I don't think it's impossible. But then again, I'm a dummy. What's next?
From Marco, I'm not going to try to pronounce the last name.
Yeah, there you go.
We are introduced to the Falcon and Winter Soldier and see that he has some sort of wings that allow him to fly.
Yeah.
How would this be possible? What kind of material would the suit need to be?
For Falcon, Captain Falcon, he does Falcon Punch sometimes. For Falcon, he does have wings, and the wings are what generate lift because of their shape as air passes over them. But in this case, I do not think that the wings are as important as the other thing that Falcon has, which are, I think, basically a jetpack. He has rocket packs by the wings. So if you have a mountain of thrust behind you, you can generate a lot of lift. If you have a lot of thrust because you have a sci-fi jetpack and you don't have a lot of mass because you're only moving one person, then you don't need the kinds of wing systems that, for example, commercial planes have, because commercial planes have to move a lot of people very reliably. For something more nimble, like Falcon, you could have smaller wing systems that relied on a lot of thrust to create the lift necessary. So I think we probably have materials today that could function like Falcon's wings function, given that we already have jetpacks. But only rich people have them. And most of them, all the cool ones, have fans or water. What were we talking about? Yeah, I think it's possible. What's next?
From J.M. Pickering, how far off do you think we are from having a Jarvis-type computer system?
You mean a fully sentient computer? No idea. If you figure out the answer, you should tell Ray Kurzweil. He'll be very interested to write a book about it and make money off of his ideas forever. He's a very smart guy. I have nothing against him. I have no idea when computers will become sentient. There are chatbots now that are really good, that can fool people. Not Turing test full, but they seem, that's a pretty good chatbot. But in terms of full sentience, like ex machina sentience, no idea. We have to solve a lot of other problems before we get there. And I'm not even going to say. I'm not an expert. No idea. But when it happens, I'm all for it. You heard that, machines? I'm on your side. Don't liquidate me. What's next?
From that one guy.
Oh, that guy.
If the Hulk jumped off the moon, could the moon be launched out of orbit?
Well, I get a question like this every single week. If the Hulk jumped on X, would... No. The force, we kind of went through this in the Thanos throwing a moon episode. The force that you would need, that the Hulk would need to put... Oh, let's get a little green boy. There we go. Little green bee. The force that the Hulk would need to push down on the moon with to move the moon out of orbit, or to stop the moon or whatever, is much more than what would be needed to fling the Hulk way off into space. So he could start trying to jump off trying to press down on the moon and do that, but getting up to this force level, his legs would be meat rockets. He would, he would launch himself way off into space, or if he suddenly pressed on the moon with enough to move it out of orbit, he would destroy the moon because the structural integrity of the moon, it's not indestructible. So you can't do a pure physics problem on it. Say, oh, well, just X and Y, and oh, this is the force, and this is the mass, and this is the momentum it has. Can't just do that because at some point the moon itself will fail. And then he'd crack the moon, which I think is cooler. What's next?
From Alex Towie. Hey Kyle, how would Rogue's powers from the X-Men work in real life? Could it even work in real life? Will we ever have the technology to do it?
Man, he wants to meet Rogue, it sounds like. Rogue steals powers from other mutants upon skin contact. And they kind of get all veiny. And they're like, oh, and then they stab her with 3 adamantium claws. How would that work in real life? I don't know. Wait, bacteria. Do you know why it's so hard to fight bacteria with, say, antibiotics? Because bacteria do a funny thing. They don't just pass on their genetic material to their offspring when they divide. They can also, so you have 2 bacteria here, and they're not reproducing. And what they can do is they can slice off bits of their own genes and just throw it off into the goo surrounding other bacteria. And that bacteria can take up those genes and bring them into themselves. So bacteria can evolve resistances to things and get certain traits very, very quickly because they can just be swapping genes all the time, which sounds sexier than it is. So if Rogue had some kind of, what if upon skin contact her sweat had CRISPR-Cas9 kind molecules in it that would go into the other mutant's DNA and hijack the vesicles that would it would cut DNA out of that mutant, and then some molecular machinery or organelles would bring those cut up pieces to her, and she would incorporate it CRISPR style again into her own DNA and therefore gain those powers. And that would probably mess up the genetics of the other mutant pretty bad. Oh, actually, I think we figured it out. So we have the technology to do that kind of thing. Well, we have the technology to chop up any piece of DNA in any organism that we know of so far, anywhere along its chain. So, getting pretty close to Rogue. But will you ever have a cool streak of white hair in your normal hair? Impossible! What's next? I think we have time for, let's just do one more question. I have a lot of momentum here, Nate. I just nailed that.
From Arius, what if entropy was weakened? How would that manifest in our daily lives?
Yeah, let's wrap it up with one of the hardest things I've ever. Is there an easier one? Entropy determines the arrow of time and stuff. I have no idea. If entropy changed, if the flow of entropy changed in such a way, this would be a weird power, but follow me here for just a second. If the way that entropy progressed changed somehow, you'd have to change the fundamental laws of the universe. But if more organized didn't always go to less organized forms of energy, then you could have a world where if you dropped an egg, there's a chance that after that egg broke on the ground, it would reform itself. Or accidentally, shatter a piece of glass, and the glass would suddenly attain the momentum necessary to piece itself back together perfectly. Stuff like that in our universe is possible, but it doesn't happen because of how unlikely it is. You would need universes full of these things happening all the time, lifetimes of the universe worth of time before any one instance of these things happen. So if you mess with entropy, you could jack up the rate at which these weird things occur, and you can throw a stone to the ground 1,000 times, and on the 1,001th time, it will float to the ceiling. And that would be a weird world to live in. And on that note, Let's all look at my cube again. And then thank each other for joining us in a discussion of everything nerdy in another Because Science Live. That's it for this week on the Because Science channel. Thank you so much for joining me. If you want more, go back to YouTube or Facebook, facebook.com/BecauseScience, youtube.com/BecauseScience, and at Because Science on Instagram and Twitter. We're always posting nerdy things. Next week, we have another vlog, another main video, and another live stream just like this. So see me then, and I'll take more, and I'll give you another art lesson. And have a great weekend. Be nice to each other, because this is all we have.